At its core, a pickup is a transducer. It converts one form of energy into another. Specifically, it takes the mechanical vibration of the guitar string and turns them into electrical signals that can be amplified and heard through the speaker. Here's how it works. A typical guitar pickup consists of three components: the magnet and pole pieces, or magnetic pole pieces, the bobbin, and the coil of copper wire. Magnets. These are usually made of a material like alnico or ceramic. They create a magnetic field around the pickup. Copper wire. Thousands of turns of very thin insulated copper wire are wrapped around the magnets, or bobbin holding the magnets. And pole pieces. This coil is key to generating electricity. The pole pieces. These are often small metal rods or screws aligned under each string, helping to focus the magnetic field. The magic happens through a principle called electromagnetic induction. When you pluck a guitar string, it vibrates back and forth. Since the strings are made out of metal, usually steel or nickel, they are magnetic. They can interact with the pickup's magnetic field. As the string moves within this field, it disturbs the magnetic lines of force. This disturbance causes the magnetic field to fluctuate. And because the copper coil is sitting right in that field, the changing magnetic flux induces a tiny electric current in the wire. The electric current generated in the coil mirrors the vibration of the string. If you pluck the string hard, it moves more, creating a stronger current, louder sound. The frequency of the vibration, how fast the string moves, determines the pitch. Faster vibrations mean higher notes. Slower ones mean lower notes. This current is super weak, though measured in millivolts, so it needs to travel through the guitar's wiring, volume and tone controls, and out the output jack to an amplifier, which boosts it into something you can hear. The pickup just doesn't capture sound. It shapes it. The strength of the magnets, the number of wire turns, and even the pickup's position under the strings, near the neck or bridge, all tweak the tone. Stronger magnets or more coils can make it hotter, louder, more aggressive, while weaker setups stay subtle and clean sounding. Imagine you're playing an open E string. It vibrates at about 82 Hertz, low E. The pickup under that string senses the vibration, turns it into an 82 Hertz electrical signal, and sends it to your amp. The amp boosts it, and boom, low E rumbles through your speaker. So in short, string vibration, magnetic field disturbance, electrical current in the coil, signal to amp, sound. That's the pickup's job. And it's why your electric guitar can scream, sing, or growl. A Fender three-way switch is a blade-style switch commonly used in electric guitars like the Fender Telecaster. Designed to select between two pickups, neck and bridge, or a combination of both. It is a bit different from toggle-style switches, both in form and function, but it serves the same core purpose, directing the pickup signal to the guitar's output. Let's break down how it works in an electric guitar. How a three-way switch works. A three-way switch is typically found in guitars with neck pickups closer to the neck and bridge pickups closer to the bridge. It has three positions, each routing the signal differently. Often a blade lever switch, like on a Telecaster, has a common terminal connected to the output and multiple input terminals, one for each pickup or combinations. Moving the switch physically connects the common terminal to one of these input positions. In the up or third position, the neck pickup is selected. The switch connects the common terminal to the neck pickup's hot wire. Only the neck pickup's signal goes to the output, giving a warm, full tone, great for mellow leads or rhythm. Middle or second position, both pickups. The switch connects the common terminal to both the neck and bridge pickups' hot wires, wiring them in parallel. This blends their signal, produces a balanced tone with traits of both. Think punchy, versatile sound. Down, or the first position, the bridge pickup. The switch connects the common terminal to the bridge pickup's hot wire. Only the bridge pickup's signal is sent, delivering a bright, cutting tone ideal for solos or sharp rhythms. Wiring insight. The pickup's ground wires are always connected to the guitar's ground. Example, via the volume pot. The switch's job is to route the hot, signal-carrying wires to the output. In the middle position, parallel wiring means the signal mix naturally, though the combined resistance of the pickups slightly lowers the output compared to a single pickup. Potentiometers. Volume and tone pots, short for potentiometers, are key components in an electric guitar's wiring that lets you shape the sound on the fly. They're simple but clever devices that control the electrical signal from your pickups before it heads to your amp. Let's break down how they work step by step. What's a potentiometer? A potentiometer is essentially a variable resistor, a small electrical component with 3 terminals that lets you adjust how much electrical resistance is in the circuit. In a guitar, it's equipped with a knob you can turn, typically rated at values like 250 k ohms or 500 k ohms, depending on the guitar and pickups. 3 terminals. One connects to the input, the pickup signal from your 3-way switch, one to the output jack or the next component, and one to ground to bleed off signal or noise. The wiper. Inside a movable contact, the wiper slides along a resistive track as you turn the knob, changing how much signal passes through versus how much gets sent to ground. Now, let's see how this applies to volume and tone. How the volume pot works. The volume pot controls how much of the pickup signal reaches the output jack, and thus your amp. Here's the process. At full volume, knob at 10. When the knob is maxed out, the wiper connects the input directly to the output. The full electrical signal from the pickup flows through with no resistance, giving you maximum volume. Lowering the volume, knob turned down. As you turn the knob down, the wiper moves along the resistive track. More of the signal gets diverted to the ground through the 3rd terminal, reducing what reaches the output. At 0, the entire signal is sent to ground, and you hear silence. How it feels. The change isn't always linear. Most guitar pots use an audio taper, which adjusts resistance gradually at first and then more sharply as you approach 0, matching how our ears perceive volume change. In short, the volume pot acts like a gatekeeper, letting more or less signal through to your amp based on where you set it. How the tone pot works. The tone pot shapes the character of your sound by controlling how much high-frequency content, treble, gets filtered out. It works with a partner, a capacitor. Here's how. Full tone, knob at 10. When the tone knob is all the way up, the wiper connects the signal straight through to the output, bypassing the capacitor. You get full range of frequency from your pickup, bright and clear. Rolling off the treble, knob turned down. As you turn down the knob, the wiper sends more signal through the capacitor to ground. The capacitor is a filter. It lets high frequencies pass through to ground more easily than low frequencies. This cuts the treble, leaving you with a warmer, darker tone. The capacitor's role. The value of the capacitor, example, a 0.022 microfarad or a 0.047 microfarad capacitor, determines how much treble gets filtered. A smaller value cuts less high end, while a larger one makes the tone muddier when rolled off. It's wired between the tone pot's wiper and ground, so it only kicks in as you adjust the knob. In short, the tone pot, with its capacitor, acts like a treble bleed valve. Turn it down to mellow out your sound, or keep it up for maximum brightness. Why two pots? Volume controls the amplitude, loudness of the entire signal. Tone controls the frequency balance, brightness versus warmth, without changing the volume much. When it comes to potentiometers in an electric guitar, the difference between audio taper and linear taper pots lies in how they adjust resistance as you turn the knob, and that affects how you perceive change in volume or tone. Let's break it down clearly and see why it matters for your guitar. What's a taper? The taper of a potentiometer describes how its resistance changes as you rotate the knob from 0 to 10. Both audio and linear taper pots have the same total resistance. Example, a 250K or a 500K, but the rate at which the resistance shifts differs, impacting how the control feels and sounds. Linear potentiometers, how they work. A linear taper potentiometer changes resistance at a constant, even rate. If it's a 500K pot, turning the knob from 0 to 5 halfway gives you 250K of resistance, and from 5 to 10 gives you the other 250K. It's a straight line on a graph. Behavior. The adjustment feels uniform. Each little turn of the knob changes the signal by the same amount. In a guitar, as a volume pot, the volume increases or decreases steadily. At 5, you get roughly half the signal strength, though your ears might not hear it as half. More on that later. As a tone pot, the treble rolls off evenly as you turn it down, with a smooth, predictable sweep from bright to dark. Audio potentiometers, how they work. An audio taper potentiometer changes resistance logarithmically. It adjusts slowly at first, from 0 to about 3 or 4, then more quickly towards the top end, 7 to 10. For a 500K pot, you may only get 50K or 100K at 5, with most of the resistance packed into the upper half of the turn. It mimics how human hearing perceives sound. Behavior. The adjustment feels more natural to our ears, which don't perceive volume linearly. A small turn near 0 has a subtle effect, while turns near 10 take a bigger jump. In a guitar, as a volume pot, the volume swells gradually at lower settings and ramps up faster at higher ones. At 5, it might sound quieter than half volume on a linear pot, but it feels smoother and more usable across the range. As a tone pot, The treble cuts slowly at first, preserving the brightness longer, then drops off more noticeably towards zero, giving finer control over subtle tone tweaks. Why our ears care. Human hearing is logarithmic. We perceive sound intensity, loudness on a curve, not in a straight line. Doubling the electrical signal doesn't sound twice as loud to us. It takes about 10 times increase in power for us to hear double the volume. Audio taper pots are designed to match this, making volume or tone changes feel intuitive and gradual, while linear pots can feel abrupt or uneven by comparison. Which is used in guitars? Volume pots. Most electric guitars use audio taper pots, often labeled with an A, like a A500K, because they provide a smoother, more musical volume swell. Turning from 10 to 7 feels like a gentle drop, not a sudden cliff. Linear pots, labeled B, like B500K, can work, but the volume might seem to plummet too fast early in the turn, making it harder to dial in a subtle level. Tone pots. It's a mixed bag. Audio taper is common here too, especially in Fender-style guitars for a smoother roll-off of treble. But some players prefer linear taper for tone, as it gives a more even sweep across the range, less bunching up of the effect at one end. Practical difference in play. Volume example. With a linear pot, going from 10 to 5 might feel like you've lost most of your volume already, while an audio pot keeps it usable longer, dropping more gradually until around 3 or 2. This makes audio pots better for riding the volume knob during performances. Example, swelling into solos. Tone example. A linear tone pot cuts treble steadily. 5 might sound halfway between bright and dark. An audio pot lingers on the brighter side longer, then darkens more dramatically below 5, which some find easier for fine-tuning. Now to assemble the components for the Telecaster control panel, volume, tone, 3-way switch, and pickups. This is how I wire a Telecaster tone, volume, and switch. I take the capacitor and I stick it through the third hole and the first hole. And leave it right on top like that. And I solder only the third. And I snip the tail off. And I bend down the other lead so it's making good contact with the potentiometer itself. Then I'll put a little flux on the potentiometer. May take a minute or two to get this hot enough. Once that's good and soldered, take my snips, cut it right at the top of the potentiometer case. Next, we'll take a short piece, and I'll run it through the second hole on the potentiometer. And just solder that real quick. There we go. Nice clean joint. Then I'll set my volume pot in place. Get a rough idea of how long of a wire I need. And that goes over to the first hole on the volume pot, along with a wire in the same pot, same hole, that'll go to our switch. Okay, then I place my switch in my little jig. And measure up to the output lug on the switch. Because this is cloth covered wire, I can pull back the insulation just about an inch or so. Cut it off. And pull it back on. And I fish this through the lugs. There's a couple different ways to do it. This is the way I was taught. And this is how the switch looks. Once I have the wire fished through, I go through the first and second on this side, then over to the third and fourth on the opposite side. And we just finished soldering up the last connection on the switch. Then I'll wire the input jack to the two wires coming from the volume pot. And we just finished soldering up the last connection on the switch. Now that I'm finished soldering the components, I'm going to temporarily hook it up to a set of pickups just to make sure everything works as it should. Take the ground wire from the pickups and hook it to the ground of the volume pot. Take a wire from the neck pickup and hook it to the last lug on the bottom row of the switch. And the bridge pickup goes to the first lug on the top of the switch. And I'll plug it into my amp. And give it a little test. That's both pickups working. Try just the bridge. Just the neck. Works perfect. And you can hear, because it's not actually grounded in a guitar, that when I touch it, the hum goes away. And that's about it. Thanks for watching. Enjoy your next build.